The long chord is crucial in staking out the simple curve using this method. Equal intervals would be ideal, and they are measured from the center of the long chord, moving outwards to the end. Perpendicular offsets are drawn from the long chord where the lengths would be measured. Then, the endpoints will be staking the curve. From the process of staking the curve with this method, the long chord should be determined, then an equal interval would have to be drawn along the long chord. Taking one interval, then projecting a certain distance until the curve is reached, a right triangle can be drawn by using the point, the sides of which can be denoted as r, the interval x, and the side which can be designated as distance OB plus the required OX. By using Pythagorean Theorem, we can say the square of the radius r is equal to the squares of the interval x and the side OB and OX. Since the required is OX, factor out the side including OX to have the square of the radius less the square of x. Take the roots to free OX and we arrive at root of r squared minus x squared minus OB. The elements in the equation from the Pythagorean theorem earlier are already known except OX, which is the required, and distance OB. In order to determine this element, let's use another right triangle with sides r, the required OB, and half of the long chord. The Pythagorean theorem can be applied once more as it is a right triangle. The square of the radius is equal to the squares of segment OB and half of the long chord. From here, extract OB squared, which can then give OB as the root of the square of the radius and half of the long chord squared. With the previous derived equation of OX, which is taken as root of r squared minus x squared minus OB, we determined OB as root of r squared minus half of the long chord squared, making the final equation for this method as O sub x is equal to the root of r squared minus x squared minus the root of r squared minus half of the long chord squared. Let's have this example. Trace the curve for the radius r given as 100 meters and the central angle delta as 45 degrees using 10-meter intervals. Adopt offset from long chord method. The long chord is needed, so solve for LC with the formula 2r sine of half of delta. The long chord is taken as 76.54 meters. If we are to have 10-meter intervals, there will be 3 points to stake at each side of the curve. So using the formula derived earlier, we can plug in the radius r of 100 meters, x as 10 meters, and half the long chord, which is 38.27 meters. The values of OX can be identified in the table. Using x as 0 will give OX as 0. At 10 meters, OX is computed as 7.1115, which locates the point on the curve at such position. At 20 meters, OX is measured as 5.5923 meters. And at 30 meters, OX is computed as 3.0067. After laying out these distances perpendicularly from the long chord, draw out the simple curve.